Strings in Python are sequences of characters used to store text data. Strings are a built-in data type used to represent text. They are enclosed within quotes and can contain letters, numbers, symbols, and white space characters. They are one of the most fundamental data types in Python and are widely used in various programming tasks, including data manipulation, user input or output, and more. Python provides several ways to create strings. The most common methods are using single quotes, double quotes, and triple quotes. Single quotes and double quotes are interchangeable for most purposes. As an illustration, name equals, in single quotes, Charlie. Message equals, in double quotes, hey there. Print name, print message. Now, we launch the program to see the results. We can choose whichever readability suits us better in a particular situation. Triple quotes are useful for creating multi-line strings. The characters we enclose within the triple quotes will be treated as a single string, even if they span multiple lines. They are particularly useful for defining docstrings or embedding multi-line content like HTML or SQL queries. Let's say text equals, in triple quotes, this is a string that spans multiple lines. Print text. Let's trigger the program run to see the output. For creating multi-line strings, we can use either 3 single quotes or 3 double quotes. You may be wondering why there are so many different ways to construct strings. This question has a straightforward answer: flexibility. Consider this example. In this example, we've used double quotes to construct a string. Let's try using single quotes instead. As you can see, this can lead to confusion. If there's a single quote within the text itself, both the IDE and the Python interpreter may mistakenly interpret that single quote as the end of the string. To avoid this issue, we can use double quotes, just as we did before. There are also scenarios where it's more appropriate to use single quotes, particularly when the string value contains double quotes. In situations where both single and double quotes are present in the text, the optimal solution is to use triple quotes. We now use the print function to display the values stored in the variables. After running the code, you will see that all the string values are printed to the output exactly as they were defined, without any issues or changes. However, as you'll learn further, escape sequences provide another way to handle these problems. Python's flexible string definitions offer more than just convenience. They enhance code readability by letting us choose the clearest quote style. This flexibility also ensures compatibility with older code and consistency with other languages. String concatenation is the process of combining 2 or more strings into a single string. In Python, the plus operator is used to concatenate strings. For instance, first name equals Jane, last name equals Smith, full name equals first name plus, in double quotes, space, plus, last name. Print full name. We press the Run button to start the code. In this example, we concatenate the first name and last name strings, separated by a space character, to create the full name string. String repetition is the process of creating a new string by repeating the original string a specified number of times. We can repeat a string using the asterisk operator. To give you an idea, separator equals dash asterisk 20. Print separator. Let's execute the script. Here, we create a string separator that consists of 20 dash characters by repeating the string dash 20 times. It's important to note that the plus operator for concatenation and the asterisk operator for repetition can be combined in various ways to create more complex string operations. Let's say we want to create an empty box using string characters, similar to the one shown in the picture. We'll need 3 print functions to create 3 rows. Here's how we do it. For the top row, we start with a special character representing the upper left corner of the box. This character has vertical and horizontal lines extending to the right and bottom. Since this character is not available on the keyboard, we use the Windows character map. Next, we create 10 dash characters using the asterisk operator. We concatenate these 10 characters to the first character using the plus operator. Finally, we add an end character for the right corner and top of the box using the plus operator. For the middle row, we follow a similar approach as the top row, but the initial and final characters are vertical bar, and the character to be repeated is a space. For the bottom row, we repeat the process used in the top row, with the difference being that we use the appropriate characters for the left and right corners of the bottom edge of the box. After writing these 3 rows, we run the code, and our empty box is displayed in the output. This example demonstrates how to combine string operators to handle complex scenarios. Strings in Python are essentially sequences of characters. Since strings are ordered sequences of characters, each character in a string has a specific index or position. Indexing starts from 0, where the first character has an index of 0, the second character has an index of 1, and so on. We can access individual characters in the string by using square brackets and specifying the index of the character we want to access. For instance, name equals Shirley. Print name, open and close square brackets, 0. Then, do the same for indexes 3 and 6. After this example is run, first line assigns the string Shirley to the variable name. Then, we use indexing to access the character at position 0 in the string variable name. Since indexing starts from 0, this corresponds to the first character. Similarly, we access the characters at positions 3 and 6 in the string variable name. The output is R and Y, respectively. Python also supports negative indexing, which allows us to access characters from the end of the string. The index -1 refers to the last character, -2 refers to the second to last character, and so on. Let's look back at the previous example. This time, we rewrite the print functions with positions -1 and -3. In this case, position -1 has access to the last letter of the string, which is Y, and position -3 has access to the 5th letter of the string, which is L, because in negative indexing, the positions are from the last to the first. You may have noticed that there are 2 ways to access a character in a string and get the same result. We can use either a positive or negative index. For instance, if we want to access the letter I, we can use index 2 or index -5. Both methods will display the letter I in the output. If we attempt to access an index that is out of range, either positive or negative, Python will raise an index error. Let's look at another example. My string equals welcome. Print my string 6. When we use position 6, it accesses the last character of the string and displays it correctly in the output. Let's see what happens if we try to access a character beyond the end of the string. If we try to access position 7, we'll get an index error, string index out of range error. This happens because we're trying to access a position that doesn't exist in the string. Strings have a limited number of characters, and attempting to access beyond that range results in an error. Slicing is a way to access a range of characters in a string. String slicing is the process of extracting a substring from a string by specifying a range of indices. It's like cutting out a piece of the string. The syntax is as follows. String variable, inside square brackets, start, colon, stop. Both arguments are optional. The starting index where the slicing of string starts. It's included in the result. If not provided, Slicing starts at index 0, the ending index where the slicing of string stops. This index is excluded from the result. If not provided, slicing continues to the end of the string. Before going back to the IDE to see a practical example, let's understand what inclusive and exclusive mean in slicing. This will help us predict exactly which characters are included in the slice string. In Python, when we're slicing a string or a list, the start index is inclusive and the stop index is exclusive. Inclusive means that the character at the start index is included in the slice. For example, in the string hello, if our start index is 1, the slice will include the character at index 1, which is e. Exclusive means that the character at the stop index is not included in the slice. So, if our stop index is 4 in the string hello, the slice will include the characters up to, but not including, the character at index 4, which is o. So, the slice includes the characters at indices 1, 2, 3, e, l, but it does not include the character at index 4. Now that we understand this concept, let's put it into practice in the IDE. Let's use the string think twice, code once, as an example. Assign this string to a variable called quote_str. Quote_str equals think twice, code once. Now, use slicing to extract different parts of the string and assign them to the substring variable. Substring equals quote_str from 6 to 11. Then, we print the substring to see the result. Or in this practical example, we take positions 6 and 11 as the beginning and end. When we execute it, we see the word twice in the output. Position 6 points to the letter T, which is the start of the substring we want to extract. Position 11 points to the comma character. However, the stop argument in slicing is exclusive, meaning it doesn't include the character at that position. So, the substring extracted will be from the letter T up to, but not including, the comma, resulting in the word twice being printed. Let's get the last 3 letters of think and the first 3 letters of twice. To do this, we type 2:9, setting the start position to 2, which is I, and the stop position to 9, which is C. Since slicing doesn't include the stop position itself, so C won't be included. That's why we get inc TWI from position 2 to position 8 in the output. Since slicing arguments are optional, if a start position is not specified, slicing automatically assumes it as 0, starting from the beginning of the string. Similarly, when the stop position is not given, it goes all the way up to the end of the string. On top of that, if both arguments are left out, a new copy of the string is simply placed into the substring variable. Negative numbers in slicing are handy for counting characters from the end of the string. For example, to get twice code from the phrase, we use 6 for the starting character and -5 to count back 5 characters from the end. Remember, negative indexing also follows the exclusive rule, so the -5 won't include the last character itself. It should be noted that when working with indexes, the position of the stop argument should not be placed before the position of the start argument in terms of indexing. If this happens, it doesn't cause an error, but it results in an empty output string because there are no characters between them. Slicing also includes a less commonly used third argument called step. The step, or stride, in a slice indicates how many characters are skipped between each index. By default, the step is 1, which means that every character is included in the slice. However, we can specify a different step to create new strings with specific patterns or skip characters. Let's consider a new example. In this case, we store the single-digit numbers 0 to 9 in the variable nom str as a string. By using the step argument, our goal is to extract the odd numbers from this string. For this, we set start to position 1 and stop to position 10. We also add a third argument with a colon and set step to 2 to skip even numbers. When we run it, the output displays single-digit odd numbers. Another interesting use of the step argument is to reverse a string. To do this, we select the entire string as substrings by leaving the left and right side of the first colon empty to default to their values. Then we add the second colon for the step argument and set its value to -1. Once the code is executed, we see the entire string reversed in the output. Python provides a wide range of built-in string methods that make it easy to manipulate and work with strings. Here are some of the most commonly used string methods. The len function is a built-in Python function that returns the length of a string, which is the number of characters it contains. This function is a general-purpose function that can be used with many types of data, not just strings. This isn't a method we call directly on a string with a dot. It's a separate function that takes a string as an input and gives us a number as an output. String methods are specific to string objects. These methods are accessed using the dot notation, and they can only be used with strings. When we type a dot after the variable, a list of methods will appear. Each of these methods manipulates the original string to create a new one. Some examples of string methods include upper and lower. The upper method converts all lowercase letters in a string to uppercase. The lower method converts all uppercase letters in a string to lowercase. The find method returns the lowest index of the substring if it is found in the string. The rfind method returns the highest index of the substring if it is found in the string. These methods are case-sensitive. In this code snippet, the find method with the argument e returns index 7, while the rfind method with the same argument e returns index 18. Both methods returns -1 if not found. In this case, the find method, when given the argument m, doesn't find a match, so it returns -1. The index method, similar to the find method, is used to locate the first occurrence of a substring within a string. However, it raises a value error if the substring is not found. After running this example, it outputs 6, which is the index where the substring repeat starts. If the substring is not found in the string, the output will display the error message value error, substring not found. The replace method accepts two substrings as arguments and replaces occurrences of the first substring with the second substring. The first argument is the old substring that will be replaced. The second argument is the new substring that will take its place. Remember, most string methods return a new string object. They don't modify the original string. In this sample code, the word simple replaces the word complex. The starts with and ends with methods in Python are used to check if a string starts or ends with a specified substring, respectively. Both methods return true if the condition is met and false otherwise. In this instance, it checks if a string begins with the and finishes with end. In both cases, the output is true. These methods check if all characters in the string belong to a specific category. In this example, the string contains both letters and numbers. The isAlpha method returns true if all characters in the string are alphabetic and false otherwise. It does not consider whitespace characters or digits as alphabetic. After running the program, the output is false because there are numbers in the string. The isDigit method returns true if all characters in the string are digits and false otherwise. It does not consider alphabetic characters or other symbols as digits. It also outputs false because the string contains alphabetic characters. The isAlpha method returns true if all characters in the string are alphanumeric and false otherwise. It does not consider white space or special characters as alphanumeric. This time, the last method returns true because the string contains both letters and numbers, making it an alphanumeric string. String formatting in Python is the process of inserting values into a string using special placeholders or format specifiers. This allows us to create dynamically generated strings by combining text with variables, function outputs, or other expressions. In Python, there are several ways to format strings, each with its own advantages and use cases. The format method, introduced in Python 2.6, offers flexibility and readability by allowing the use of named placeholders and various formatting options. The most modern approach is f-strings, introduced in Python 3.6, which provide a concise and efficient way to embed expressions directly within string literals using curly braces and prefixed with f. Each method provides unique features and can be chosen based on specific requirements and the version of Python being used. We will explore string formatting techniques more in depth, focusing on the format method and f-strings. The format method is a powerful and versatile way to format strings. It allows us to insert values into placeholders within a string template, providing control over the formatting of those values. Curly braces are placeholders where the values will be inserted. The format method takes one or more arguments, and these values are inserted into the placeholders within the string, replacing the curly braces placeholders. This method is called by putting a dot right next to the string statement or variable. Now, let's return to the IDE to see how to use it with some examples. Name equals Brian. Age equals 25. Print open and closed curly braces as a placeholder is open and closed curly braces, years old, right next to the string, dot, format, name and age as parameters. In this example, curly braces placeholders are replaced by the values of name and age, respectively. The result shows that Brian is 25 years old. We can specify which value to insert into which placeholder by using index positions. Index positions start at 0 and increment by 1 for each placeholder. For example, here, the first curly braces get 0, and the second gets 1. Let's run the code again. The output stays the same. We can assign keywords to our placeholders, allowing for more readable and understandable code. For instance, x equals 5, y equals 10, text equals the sum of curly braces x and curly brace y is curly brace sum. Print text dot format x equals x, comma, y equals y, comma, sum equals x plus y. Here, we're assigning the values 5 and 10 to the variables x and y, respectively. In the third line, we're creating a string variable name text that contains placeholders x, y, and sum. These placeholders will be replaced with the corresponding values when we use the format method. And the last line is a call to the format method on the text string. Inside the format method, we're passing keyword arguments. X equals x argument tells the format method to replace curly brace x in the string with the value of the variable x, which is 5. Y equals y argument tells the format method to replace curly brace y in the string with the value of the variable y, which is 10. Sum equals x plus y is the most interesting part. Here, we're not just providing a variable value. We're actually calculating the sum of x and y, which is 15, and assigning it to the keyword sum. Then, this value 15 is inserted into the third placeholder. The format method returns a new string with the placeholders replaced by the corresponding values. So, when we run this script, the print function outputs this formatted string to the console, which would be the sum of 5 and 10 is 15. The format method also lets us format numbers. such as adding commas for thousands or controlling the number of decimal places. When using string formatting, we can optionally provide a format specification for each field. The format specification is preceded by a colon after the field name or index. To give you an idea, first, we store a large number in a variable called number. Our goal is to add commas for every 1,000. To do this, we pass the number variable as an argument to the format method. To format the output text, inside the placeholder, we put a colon followed by a comma. When we run the code, the output will display the large number with commas for every 1,000, making it easier to read. Consider another example. We assign the value of pi with many decimal places to a variable named pyprecise. Now, we want to format the output to show only 2 decimal digits. This time, we explicitly specify the argument keyword in the format method. In the placeholder, we put the keyword pi, followed by a colon and then the specifier for the decimal number. In this case, since we want a decimal number, we add dot, 2, and F. The letter F stands for fixed point number format, meaning the number should be displayed as a floating point number. After running the code, the output shows the number pi with 2 decimal places, which is 3.14. The colon separates the different parts of the placeholder. In this example, it separates the keyword pi from the decimal specifier 0.2f. If a part is not available, we can simply leave it empty, as shown in the previous example. Python's format method goes beyond simple formatting like commas or decimals. It offers a mini-language for precise control. We can define alignment, field width, signs, data types, padding, conversions, scientific notation, and more. This versatility makes the format method essential for creating well-structured and visually appealing output in Python programming. F-strings, also known as formatted string literals, allow for easy string interpolation and formatting. Their primary goal is to place values within strings in a clear and straightforward way. F-strings are faster and more readable than other string formatting methods. F-strings are prefixed with the letter F, lowercase or uppercase, before the string literal. The expressions inside curly braces are evaluated, and their values are inserted into the string. Let's return to the IDE and explore some practical examples using F-strings. Width equals 1920. Height equals 1080. We first set the width and height variables. Then, print f, image resolution, curly braces width, x, curly braces height. The string starts with the letter F before the opening quotation mark. This indicates it's an F string. Curly braces within the string act as placeholders where the values of variables or expressions will be inserted. We've already seen how curly braces work with the format method. With F-strings, the difference is that the curly braces and variables inside the string are color-coded differently in IDEs like Clipchamp. This is because F-strings are recognized as formatted string literals, and the IDE understands that the values of the variables will be inserted into the string. If we remove the F prefix from the beginning of the string, the entire string turns green, indicating that it will be treated as a regular string literal, and the contents inside the curly braces will not be interpreted or replaced with variable values. Let's re-add the letter F to the beginning of the string and run the program. The output shows the variable values correctly inserted into the string. Python evaluates the expressions inside the curly braces at runtime and replaces them with their corresponding values in the resulting string. This allows for dynamic string interpolation and formatting. For instance, print f with an aspect ratio of curly braces width divided by height. This line uses an F string to print a formatted string to the console. The expression inside the curly braces is a division operation that calculates the aspect ratio by dividing the width by the height. When we run this code, it will print with an aspect ratio of 1.7, repeating sevens. In some cases, we don't need such a large number of decimal places. To limit the number of decimal places in an F string, we can use specifiers, similar to the format method. The colon separates the variable from the specifier. We put .to and F. F stands for fixed point number. After execution, the output shows 1.78. The repeating decimal was rounded up to 2 decimal places, so 1.7, repeating sevens became 1.78. F-strings can certainly span multiple lines, which can be very useful for formatting longer strings, or when working with large amounts of data. Let's look at an example of a multiline F-string. Name equals Charlotte. Job equals software engineer. Salary equals 150,000. Let's display these three variables on the screen, but with a specific format in mind. Print F, triple double quotes. Name, colon, curly braces name. Job, colon, curly braces job. Salary, colon, $, curly braces salary, colon, comma. We press the Run button to start the program. The print function shows a neatly arranged multi-line text on the output. Here's what's happening. This part uses a multi-line F string to format a string that spans multiple lines. The F before the triple quotes indicates it's an F string. This allows us to embed expressions inside curly braces. These expressions are evaluated and replaced with their corresponding values. Here, name inside curly braces is an F-string expression. The value of the variable name, which is Charlotte, is inserted at this position. Similarly, for the job and salary variables, the colon-comma specifier formats the number with a 1000 separator for better readability. F-strings are often more readable and concise, making the code easier to write and understand. They are particularly useful for quick, inline formatting of variables and expressions. They are also faster in terms of performance. The format method is useful when we need to format strings with complex data structures, or when the formatting logic needs to be separated from the string itself. It provides more control over formatting options and can be more readable in certain cases. The format method is also compatible with older versions of Python, making it necessary for maintaining legacy code. Both are used for string formatting when we want to insert values into a string. The choice between the two often comes down to personal preference and the specific requirements of our code. As you saw earlier, in Python, some characters have special meanings and cannot be directly included in strings. To avoid confusion, we can generate strings using single, double, or triple quotation marks. However, this method only applies to quotes. For other cases, Python offers escape sequences. Escape sequences in Python are backslash characters followed by a single or multiple characters that represent a special meaning or functionality. They are used to include characters in strings that would otherwise be difficult or impossible to represent directly. Here are some common escape sequences in Python. Let's look at this sentence. Print, it's not a bug, it's an undocumented feature. Since it contains single quotation marks, we would typically use double quotation marks to print it. However, using a single quote within the string would cause a conflict. To resolve this, we can use escape sequences by adding a backslash before the single quotes inside the string. The backslash tells Python to treat the single quote as a regular character, not as the end of the string. In PyCharm, escape sequences are highlighted in a different color to make them stand out. Let's consider the same example sentence as before, but this time we'll enclose it in double quotes. Now, suppose we want to place the word undocumented within double quotes. To avoid errors, we can again use escape sequences. By inserting a backslash before the double quotes inside the string, we ensure that Python interprets the quotes correctly as part of the string, rather than as the end of the string. \n inserts a line break, moving the cursor to the beginning of the next line. For example, print premature optimization \n is the root of all evil. The output shows a break at the \n in the sentence. \t inserts a horizontal tab space, often used for indentation or alignment. For instance, print "this is a \t tabbed string." The output shows an extra tab in the sentence. If we have a single backslash in a string, Python will treat it as an incomplete escape sequence and give us a syntax warning. This is because the backslash is usually used to start an escape sequence. However, the code still runs and prints the output because a warning doesn't stop the program like an error does. To include an actual backslash character in a string, we need to use its escape sequence, which is two backslashes together. This is especially common when working with file paths on Windows, which use backslashes as separators. By using two backslashes, we ensure Python includes the backslash in the path correctly. Let's execute the program. The string is printed correctly without any warnings. Consider an example similar to the previous one. While this code works fine, the frequent backslashes make it less readable and not very efficient to input. To improve this, it's recommended to use raw strings. Raw strings are a way to create string literals without interpreting escape sequences. They are prefixed with R, lowercase or uppercase, before the opening quote. Now let's modify this example using a raw string. We first add the letter R before the opening quote of the string. Then, we can remove the extra backslashes that were used as escape sequences. The backslashes are treated as literal characters, and no escape sequence interpretation occurs. You'll notice that Pycharm no longer highlights backslashes differently. This makes our code cleaner and easier to read, and of course, it will still print correctly when we run it. Raw strings are particularly useful when working with regular expressions, Windows file paths, or any string that contains many backslashes.